Hi everyone, so in this video I want to discuss something called the list iterator with you, and let me just first tell you why we need something called a list iterator. So take a look at this piece of code right here. So what's going on here is we are iterating from 0 to n for a linked list, and we're getting the element at the ith index right here. So if we try and calculate the complexity of this code right here, the linked list dot get is itself linear. So this is order of n, and we're going to do this n times. So it's going to be order of the entire thing is going to be order of n square. So that's really slow for a really big long linked list. It's going to take really long. So let's take a look at what exactly is going on here. I have a linked list something like this: 1, 2, 3, 4, and so on. Now what's going on is we get the first element first, we print out this 1, then we go from this 1 to 2, we print out this 2. Now the second time, or actually the third time this runs, we start from the 1 again, we go to the 2, and then we go from 2 to 3, and we print 3. So basically what I'm trying to say is that in the n-1th iteration, we've already reached the n-1th node, but in the nth iteration again, we start from the first node. So that's what's making this really slow. If we wanted to do it better, what we could do is maintain a node. So I create a node, and in that I store the node that I'm at. So let's say I'm at this 3, I store this 3 here, and I print this if I want, and then I move to the next node. I go from 3 to the 4, and I then store the 4 here. So that way I'm storing the current node that I'm at, and then I'm just moving forward. That would be traversing the linked list only once, and we can get it done in linear time. So we can do this in order of n time. So what's the issue with this is, let's say I'm maintaining the node 4 and I accidentally end up changing the data in the node itself. Instead of a 4, I accidentally do a +1 here, and this becomes a 5, and my whole thing starts behaving weird. So we don't want to do that. So what we do is we make something called a list iterator. So what exactly is a list iterator? A list iterator is basically just something that maintains the uh, position. So let's see, this is the linked list, and so on. What the list iterator does is let's say I have this list iterator right here. So it'll first contain this 1, and it won't let us change the value here. We could of course add or remove nodes using a list iterator, but we still can't modify the value in a node. So what it does is, when I say list iterator dot next, it actually has a dot next method. So if I do this, it gives me this 1, and then it itself starts pointing to this 2. So a list iterator most intuitively can be thought of as the cursor. So let's say I have Shreyas written here, and I have my cursor right here, let's say. So this is my list iterator. It's set to be between R and E. In reality, it just points to the E, and if I use the next method, it would just give me the E and then move to between E and Y. So that's what it does. And list iterator also has methods like has next. So if we wanted to write some list iterator code, we would go about doing it something like while list iterator, let me just call it iterator dot has next, and then we would write the code whatever we wanted right here. So we can here get the next element of the list and then keep moving forward. So this is what the list iterator does. And let's say I want to add something here. So just like in a Word document, when the cursor points right here between the R and E, if I hit an A, let's say, where would it add? It would be between the it would be just after the R. So that's what the list iterator does. It If I hit an E here, it would be something. If I hit an A here, it would be something like this. My cursor would still be here, and then the rest. So this thing got added, and we could also do a remove, and remove is very similar to hitting the backspace. So if I hit remove, it would remove this. But there's one little point that you must always remember, that remove can only be called after we have called a next. It can't be called after a remove or after an addition. So we can't have two removes consecutively. We would have to have a next between them. And there's a simple reason behind it. Let's take a look at this. If let's say iterator dot next equals let's say A, then iterator dot remove. So look at this thing right here. What I did is, if iterator dot next equals A, I want iterator dot remove. So basically what I want to do is remove all instances of A from the string. So I just checked for an A and then did a remove. The only thing is that when I hit the next, the cursor also goes forward. So if I had something like Z B A C D and I was here, then when I did the next, it would still go here, and I also did a check. So I got this A from the next, and I checked this for an equality with an A. So I got a true here, and then I did remove. So that is why naturally it should remove the element just before it. So it removes this A. So remove removes the previous element. So previous or just before the list iterator. And in case of a doubly linked list, a list iterator would also have a previous and a has previous method. So that's another thing to remember. And that kind of wraps up the discussion on list iterators. And next time I want to show you something really interesting about array lists that I found out. So I think I'll take a programming session for that. It'll be really fun, so stay tuned for that.